Hi, boys and girls. It's Miss Bissell. Today we're working on lesson 4.3. We're going to be starting with using models to multiply a decimal and a whole number. We're going to move into actually doing this without the models. So we need to be in our books on page 178. We are in volume 1, and our essential question to guide us through the lesson is, how can you model multiplying a decimal times a whole number? So in our visual learning example, we have Bari, who displayed 4 paintings side by side in a row. Each painting has the same width. What is the total width of the 4 paintings? The 5th grade helper says that we can use multiplication to find the total width. And each painting, we're told, is 36 hundredths of a meter wide. So the first thing we're going to do is we are going to round our decimal number to the nearest tenth. 36 hundredths rounds to 4 tenths. So 4 groups of 4 tenths, 4 times 4 tenths is going to give us 16 tenths, which is 1 6 tenths. So the answer should be close to 1 6 tenths. And what we know is that our estimate is actually a little bit over the actual product, since 36 hundredths is less than 4 tenths, which is the equivalent decimal to 40 hundredths. Then 1 6 tenths is going to be an overestimate. All right, we can find 36 hundredths times 4, or 4 times 36 hundredths. It's like adding 36 hundredths 4 times on a hundredths grid. So we do know that multiplication is just simply repeated addition. So here in our hundredths grid, they are going to shade 36 hundredths, 36 of these 1/100th parts red, 36 hundredths green, 36 hundredths blue, and 36 hundredths orange. When we look at the product, we're looking at everything shaded. So we see that we have one whole shaded, and we have 10, 20, 30, 40, 1, 2, 3, 4, 44 hundredths of a second decimal grid shaded. So our product that we're looking at is 1 44 hundredths. All right. Now, I'm going to go ahead and show you how to do this without the models, because this isn't that practical. Most people don't carry models around. So when we're looking to find the product of 4 36 hundredths, all right, we're going to stack it up with the number with the most digits on the top. So we're going to have 36 hundredths times 4. We're actually going to multiply as if 36 is a whole number. We're going to ignore the decimal for a minute, okay? So 4 times 6 is 24. Whoops. 4 times 3 is 12. We add our 2 to get 14. 4 times 0 is 0. We add our 1. And this is what's getting ready to happen. We notice that when I ignored that decimal in 36 hundredths, and I just really multiplied as if I had 36 times 4, what I'm really doing is I'm multiplying this factor times 100 to move that decimal out of it. So what I have to do is, in my product, I have to compensate for having moved that decimal out of it with multiplication, and I have to move the decimal back in with division. So I would have to move it back in. So what you will hear a lot of people say is that the number of decimal places in your factors should be the number of decimal places in your product. So I get an answer of 1 44 hundredths. Now, I should have done my estimate first, but always better to do it last than never. So if I'm going to estimate 3,600, I'm going to round to the nearest tenth. I'm going to multiply it by 4. 4 tenths times 4 gives me 16 tenths, or 1 6 tenths. Okay? My answer, 1 44 hundredths, is relatively close to 1 6 tenths, or its equivalent decimal, 1 60 hundredths. All right. So we are going to make sure we understand how to draw the model. Okay, we can look back through our visual learning example, but for today, we're really going to try to go ahead and do this without models. So let's go ahead and jump right in on page 179. All right. If you need to use the decimal grid, that's fine. You're going to have to draw some on graph paper. Don't forget you're drawing 10 by 10 squares. All right. And on most of these, you're going to need more than one decimal grid to answer. All right, numbers 2 through 5. We're going to find the product. Now, let's talk about it. 8/10 times 4. All right, we could do this. What 8/10 times 4? 8 times 4 is going to be 32, right? So 8/10 times 2, what we need to do is we need to have one decimal digit behind, well, let me scoot over here. We need to have one decimal digit in our answer, because what I did was I multiplied 8 times 4. So what I had done, without even think about it, I had moved that decimal out of the number out of this factor by multiplying it times 10. So I need to move it back into the product. Okay. So let's look at 7/10 times 21. So let me just do my work over here. 7/10 times 21. 7 times 1 and 7 times 2. So 21 times 7 is 147. So I have this one decimal that I've mentally moved out of the way. I need to move it back in. So I need one decimal digit. So my answer is going to be 14 and 7/10. All right, let's look at this one. 6 times 5 we know is 30. So what I just mentally did was I moved that decimal out. So I need to move it back in. So I need to have one digit behind the decimal point. So 5/10 times 6 is 3. Okay. So we could write it 3.0 or 3. All right. Our last one right here, 5 times 6/10. Well, wait a minute. 5 times 6 is 30. So if I am multiplying by the whole number, I mentally moved it out of this factor by multiplying by 10. So I have to divide by 10 and move it back in. So look at this. I get the answer 3 and 0/10, or just good old 3. Now, why are these two answers the same? Did anybody pick up that what we have are basically the same factors? All right. One of them we made tenths. And then in number 5, we made the other factor tenths. All right. Again, you're welcome to use the models. Let's just make sure we understand them. So for number 6 and 7, we are going to be multiplying for number 6, 55 hundredths 3 times. So if we do that, 5 rows would give me 50 hundredths. And then 5 here. All right, there's one group of 55 hundredths. So I need another group of 55 hundredths. There's my 5, 15, 25, 35, 45. And then I need one more group of 55 hundredths. 20, 30, 40, 50. And then 5. All right, so what I have here is one whole, and on this one I have 55 hundredths. So I get one, whoops, I did something terribly wrong, didn't I? 55, and that was 5, 10, 20, 30, 40. Oh my goodness, look at that. That needed to be another row of yellow. And here I needed 5 rows. I'm one short. And here. All right. So no, it's not 55 hundredths. It's 65 hundredths. I have 6 columns and then 5 of another column. So 1 and 65 hundredths. All right. Those models are awfully little. All right, so what I have here, let's just look at this, is if I set it up with traditional multiplication, and I multiply this as 55 times 3, don't I move this decimal out by going 2 places? All right, so watch what happens. 3 times 5 is 15. 3 times 5 is 15 plus that 1, 16. 3 times 0, 0 plus 1. And then I move this out by multiplying the first factor by 100. I need to compensate and put that decimal back in. So I'm going to go back in 2 digits behind the decimal point, 1 65 hundredths. I know my answer is correct. All right, let's see if I don't do a little bit better on this next one. I'm multiplying 45 hundredths times 2. So I need 4 columns, 2 and 5. All right, and then I need another color of 45 hundredths. So let's do this 5. That would, and then, okay. So what I see shaded here, 9 columns, which would be 90 hundredths or 9/10 we could call it. Okay. Now let's check it with standard multiplication. All right, so we're going to treat this as 45 times 2. 2 times 5 is 10. 2 times 4 is 8 plus 1 is 9. 2 times 0 is 0. We're treating this as 45, so we multiplied that first factor pretty much by 100. So we need to compensate and move that decimal back in with division. So here we get 90 hundredths, which we all know we could rewrite as 9/10. So our model work is correct. All right, if you want to pause me and do a couple of these on your own and then check and see how you're doing, that would be great. Otherwise, I'm going to work a couple of these out on notebook paper. If you do that, we can do that. We're on lesson 4.3 and we are on page 179. All right, so number 8. Again, I'm going to work this out traditionally, okay? So what we're going to do is we're going to write this. The number with the most digits is going to be our top factor. So we're going to have 5/10 times 500, times 5, the whole number. We're going to treat these as 2 whole numbers. 5 times 5 is 25. All right. We have 1 digit here in our factors, so we need 1 decimal digit place in our product. So the answer is 2 5/10. Okay. Number 9, we're multiplying 27 hundredths and 4. All right, 4 times 7 is 28. 4 times 2 is 8 plus 2 is 10. 4 times 0 is 0. 0 plus 1. We have 2 decimal digits in our factors. We need 2 decimal digits in our product, and we've talked about the why of that. All right, number 10. We're going to multiply 13 hundredths times 6. All right. Again, I can move the factors. I can switch their places. Because of that commutative property of multiplication, I'm still going to get the same product. So for standard algorithm of multiplication, we need the number with the most digit places on the top. 6 times 3, 18. 6 times 1, 6 plus 1 is 7. 6 times 0 is 0. All right, I need 2 decimal digits in my product because I have 2 decimal digits in the top factor. My answer is 78 hundredths. All right, number 11. We're multiplying 78 hundredths. Let me move my paper a little bit. Times 5. And again, we're just treating this as multiplying 78 times 5. Our 5 times 8 gives us 40. 5 times 7 is 35, plus those 4s, 39. 5 times 0 is 0. We add the 3. We put in 2 decimal digits because we have 2 decimal digits in our first factor, 3 90 hundredths or 3 9/10 would be the equivalent decimal. Either way you want to write that would be correct. All right, go ahead and pause me and work maybe the next row, and let's see how you did. Okay, boys and girls, here are my answers with my work shown for 12 to 23. If you notice, I did not use the models. I used the understanding of the fact that I'm really working this out as standard multiplication, where I'm multiplying two whole numbers, and then I'm going back and looking to see how many decimal places are in my decimal factor, and I'm placing those same number of decimal places in my product, okay? So here are my answers. If you have any questions, we can talk about it during our video chat session today. You are welcome to draw models, but I think if you look at a problem like number 23, I don't think you're going to want to draw 14, 15 decimal grids. All right, so if you are understanding how we are getting these answers with the explanation that what you did was you were really multiplying two whole numbers and you were using compensation to move the decimal out of the one factor using multiplication and putting it back in the product by using division, then you're good to go. All right. So if you have any questions, come visit me in the video chat this morning from 9 to 11 and we will talk about it. Otherwise, have a good day and I will see you tomorrow.